Alright, so this chapter we're going to start getting into hydrostatics and fluid dynamics. Now hydrostatics, fluids aren't moving, and fluid dynamics when they are moving. Let's begin by talking about a fluid. A fluid can be a gas or a liquid. A fluid can occupy the shape of its container. So in fluid dynamics, or hydrostatics, mass is not used. Instead, we take the mass and we put it inside of some kind of volume. And that's what we refer to, and this is called density. So density is mass per unit volume. Here's a volume. I'll put some mass in it. So here are my little SpongeBobs, or mass, whatever I have in there. So this mass divided by this volume, that gives me a certain number, which is our density. If I want to increase the density, what I'll do is I'll put more mass inside of the volume. So here I'm adding up more mass, by putting more mass inside the same shape, I've increased the density. Same size object, but it's heavier now. So the density is increased. Alright, so density is mass per unit volume. The letter we use to represent density is the Greek letter rho. So it looks kind of like a lowercase p, except it's a little bit more elegant when it's drawn. It's not so straight up and down the left-hand side. It's drawn a little more elegantly. And that's the density. So rho is density in fluid dynamics. And that's a kilogram per meter cubed. Capital V is volume. Capital V, not lowercase v. Lowercase v is velocity. So when I'm writing this by hand, I look at my capital V in order to emphasize that it's a capital letter on my hand notes. What I'll do is I'll draw it something like this. And what's different is, when I'm drawing it, I'll make sure that I have these little serifs, these little horizontal lines on the top of my V, and that represents to me that that's a capital V, and that's what I mean by it. Volume is measured in meters cubed, and mass, of course, is measured in kilograms. So, we don't really talk about density so much, we don't talk about mass so much, we're talking about density. However, we are going to relate things back to mass. So when we're doing that, sometimes it's nice to think of mass as volume times density. So another little equation to look at. Remember, that's the Greek letter rho, not a lowercase p. So volume times density is mass, and this way we can substitute into some of our previous equations. For example, in classical mechanics, we know the kinetic energy is 1/2 mv squared, and the potential energy stored in gravity is mgh. In fluid dynamics, we can take that energy and divide it by unit volume. When we do that, it changes our masses over into densities. So now the kinetic energy per unit volume is 1/2 rho v squared, and the potential energy stored in gravity per unit volume is rho gh. And this is really helpful when we're starting to make connections to what we've previously learned.